Today we will see the illustrations on the various properties of the complex numbers. First we will write the complex number in a proper form. Write the complex number in the proper form. That is, if the complex number is given as first 1 upon 3 minus 4i. It is not written in a proper form. Proper form is a plus ib. Now we have to write the complex number in this complex number in the proper form. That is 1 upon 3 minus 4i. You multiply the conjugate of this complex number in the numerator and denominator. So it will become 3 plus 4i divided by 5. That is 3 by 5 plus 4 by 5i. It becomes in the proper form, that is a plus ib. This is a, this is ib. Now we come to the second example. 1 upon 1 minus 2i plus 3 upon 1 plus i. And it is multiplied to 3 plus 4i upon 2 minus 4i. Now you have to write this complex number in the proper form, a plus ib. So first we solve first bracket, that is 1 upon 1 minus 2i plus 1 upon 3 upon 1 plus i. It is multiplied to 3 plus 4i divided by 2 minus 4i. Take the LCM, 1 minus 2i into 1 plus 3i. It becomes 1 plus i plus 3 into 1 minus 2i. Then 3 plus 4i divided by 2 minus 4i. If you solve the first bracket, you will get 4 minus 5i divided by, multiplied the two complex number 1 minus 2i and 1 plus i in the denominator. That is, you will get 1 minus 2i minus plus i minus 2i square, that is plus 2. It will become 3 plus 4i into 2 minus 4i. 4 minus 5i, it will become 3 minus i, and in denominator 2 minus 4i, and it is 3 plus 4i in the numerator. Again, the multiplied the two complex numbers in numerator and denominator. We will find that 12 minus 15i plus 16i minus 20i square, that is plus 20, divided by, this is 6 minus 2i minus 12i plus, that is 4i square. I square becomes minus 1, then it will become minus 4. So in numerator we will get 32 plus I, and numerator and in denominator we will get 2 minus 14i. Again we rationalize it. 32 plus I divided by 2 minus 14i. Multiply both numerator and denominator by 2 plus 14i. In denominator you will get 4 plus 196, and numerator you will get 64 plus 2i plus 14 multiplied to 32, that becomes 448i plus 14i square. I square is equal to minus 1, so numerator will become 50 plus 450i divided by 200. It will become 1 by 4 plus 9 by 4i. So we have seen two illustrations of complex numbers writing in a proper form of a plus ib. Now let us use more properties of the complex number in the coming examples. Let us see. Suppose example 3, given as 1 plus z upon 1 plus z bar. You have to find out the value of 1 plus z upon 1 plus z bar, given mod of z is equal to 1. You can solve this problem by two methods. You take z is equal to x plus iy, and if you solve 1 plus z upon 1 plus z bar, it will become 1 plus x plus iy divided by 1 plus x minus iy. 1 plus x plus iy upon 1 plus x minus iy. If we do it by simple method of rationalization, then you multiply both side, numerator and denominator, by the conjugate of the denominator, that is 1 plus x plus iy and 1 plus x plus iy in the numerator. numerator will become 1 plus x plus iy to the power 2, and denominator will become 1 plus x square minus I square y square, that is y square. Mod of z is equal to 1 is given, so z is equal to x plus iy. Mod of z is equal to 1, so root of x square plus y square is equal to 1, that is x square plus y square is equal to 1. Now let us come to the numerator, that is 1 plus x square plus I square y square plus 2x plus 2xyi plus 2iy divided by 1 plus x square plus 2x plus y square. It is equal to 1 plus x square, I square becomes minus 1, that is minus y square plus 2x plus 2xyi plus 2iy divided by 1 plus x square plus y square plus 2x. X square plus y square will become 1. So you can put 1 minus y square is equal to x square in the numerator, that is 2x square plus 2x plus 2xyi plus 2iy divided by denominator will become 1 plus 1 plus 2x. So numerator is equal to 2x square plus 2x plus 2xyi plus 2iy divided by 2 plus 2x. Take 2x as common, that is x plus 1. Here 2iy, that is x plus 1. Then it will become 2 into 1 plus x. You cancel 1 plus x from both sides, you will get x plus iy. So it is equal to z. But it is a long method. If we use the properties of the complex numbers in this question, then see it, 1 plus z upon 1 plus z bar. You have to find out the value of 1 plus z upon 1 plus z bar. Now mod of z is given as 1. Then mod of z to the power 2 is equal to 1. So z into z bar will become 1. Now you put the value of 1, z into z bar plus z upon 1 plus z bar. So you take the common z, so 1 plus z bar divided by 1 plus z bar. It will cancel out, it will become z. So in the previous method, we took 6 steps to solve the problem, where if we use the properties of the complex number, we can solve it in the 2 steps. Let us see next illustration based on the properties of the complex numbers. That is illustration 5. Mod of z1 is equal to mod of z2 is equal to mod of z3 is equal to mod of 1 by z1 plus 1 by z2 plus 1 by z3 is given as 1. Now we have to find out the value of mod of z1 plus z2 plus z3. Now mod of z1 is equal to mod of z2 is equal to mod of z3 is equal to 1. By squaring both sides, we can write it mod of z1 square mod of z2 square mod of z3 square is equal to 1. This is at z1 bar is equal to z2 bar is equal to z3 bar is equal to 1. Now 1 can be written as, if we take mod of 1 by z1 plus 1 by z2 plus 1 by z3 is equal to 1. If we put z1 bar in place of 1, then it becomes z1 bar divided by z1, z2 bar divided by z2 plus z3 bar divided by z3 is equal to 1. Now mod of z1 bar plus z2 bar plus z3 bar is equal to 1, and we know the property that mod of z is equal to mod of z bar. So we can write mod of z1 plus z2 plus z3 whole bar is equal to 1. We can write mod of z1 plus z2 plus z3 is equal to 1. This is the fourth example of the properties of the complex numbers. Now we again come to the next example, which is more illustrative and which will tell you the importance of the properties of the complex numbers. Given mod of z is equal to 1, given is alpha and beta are two complex numbers such that mod of alpha is equal to 1. Then find the value of mod of alpha minus beta upon 1 minus alpha bar beta. Alpha and beta are the two complex numbers, are the two given complex numbers, we have to find out the value of mod of alpha minus beta upon 1 minus alpha bar beta. Mod of alpha is given as 1, so mod of alpha to the power 2 is equal to 1, then alpha into alpha bar is equal to 1. Now mod alpha minus beta upon 1 minus alpha bar beta is written as alpha minus beta divided by 2. You can replace 1 by alpha bar minus alpha bar into beta. Now by the properties of complex number, you know that Z1 upon Z2 is equal to mod of Z1 divided by mod of Z2. Now mod of alpha minus beta divided by mod of alpha bar into alpha minus beta. This becomes mod of alpha minus beta divided by two complex numbers are multiplied together, and if we take the mod of Z1 into Z2, it becomes mod of Z1 into mod of Z2, like this. Z1 into Z2 whole mod is equal to mod of Z1 into mod of Z. So in denominator we can write mod of alpha bar into mod of alpha minus beta. The mod of alpha minus beta in numerator and denominator cancels out, so we get 1 by mod of alpha bar. It will become mod of alpha, and mod of alpha is given as 1, so it will become 1 by 1, so it becomes 1.